Hello everyone, welcome to the fourth part of the first lecture in EEE 25. We're still in the topic of probability models and axioms. We ended last time discussing uh, probability law, and our lecture was focused on axioms of probability and other properties associated with probability values that can be derived from these axioms. This part of the lecture will be focusing on calculating probabilities associated with events in the sample space. So once we have completed our probability model, it's time for us to poke through that model and get some information about events of interest. So this part of the lecture consists of examples, which will allow us to get a good idea on how to calculate probabilities. We start with our first example. Recall our experiment involving rolling a four-sided die twice. So we know that such an experiment would yield discrete outcomes, and the outcomes are finite in value. Specifically, there are only 16 possible outcomes for this particular stochastic experiment. We use a grid to facilitate uh, the listing of all the outcomes of this experiment. And to complete our probability model, we need to uh, employ or specify a probability law which will assign a probability value for each of these outcomes right here. And assuming that we have a fair die, so it's not a loaded die or a biased die. So we can assume that every possible outcome has an equally likely chance of occurring, and since there are 16 possible outcomes, each outcome would have a probability of 1 over 16. So this is our probability model right here, and now we can ask questions. And let's say we want to find out the probability of the following events. So the first one would be the probability that the first row is a 1. The second question involves getting the probability that at least one row is equal to 2. And the third and final question is the probability that the sum of the rows is greater than or equal to 7. To answer these questions, all we need to do is look at our sample space and look for outcomes that satisfy or that fit in the description stated in the question. And to illustrate, we start answering with the first question. So here, what is the probability that the first row is a 1? Looking at the sample space right here, all the outcomes in the first row of the grid satisfy that description. So there are 4 outcomes in total, and to get the probability, all we need to do is divide that number with the number of possible outcomes in the sample space, and that's equivalent to 4 over 16, or simplifying the fraction, what we get is 1 over 4. We do the same thing for the next two questions. The second one is, what is the probability that at least one row is equivalent to 2? So looking at the sample space on the left, we see that 7 outcomes fit that description. So these outcomes right here have the first row equivalent to 2. These outcomes on the second column from second row from the bottom have their second row equal to 2. So since we have 7 outcomes satisfying that description, we divide that with the total number of outcomes. That's 16, so we get the probability value of 7 over 16. And for the third question, what is the probability that the sum of the rows is greater than or equal to 7? Looking at the again at the sample space on the left, so we see that this outcome right here, this outcome right here, and this outcome right here fit that description. So the sum of these two guys right here is 7, this is all 7, and this one is 8. So that's 3 out of 16. So the answer to this question is 3 over 16. So here, the model that we use is we assume that all of the possible outcomes are equally likely to occur, and the term, the technical term for that is the discrete uniform law. And basically what it says is that if we are given a sample space omega that has n possible and equally likely outcomes, then if we consider an event A as which is a subset of the sample space capital omega, and that event consists of k outcomes, then the probability of this event is equivalent to the ratio of the number of outcomes in the element in the set A divided by the number of outcomes in the sample space, or simply k over n. Now, for practice, I want you to answer these two probability questions on the same experiment. So I want you to find out the probability that the sum of the rows is divisible by 3, and the probability that the first row is greater than the second. So it might take you a bit more time, but not too much for you to answer these questions. But I'm sure if you follow the how we solved the previous examples, I'm sure you'll get this right away. So that is for a sample space with discrete and finite number of possible outcomes. Now, what if our sample space would have infinitely many outcomes? And recall our experiment of throwing a dart to a square of unit area, which is shown right here. Now, if we assume that dart would always hit the square, so it's impossible that the dart would hit this one or this one, just maybe on the sides of the square or inside the square. Based on that assumption, we need to answer these two questions. Now, this is your sample space right here. All ordered pairs, points inside and on the side of this square. Now, what would be a probability model that what would be a probability law that we can use? So the simplest case would be to use the uniform probability law, but since we're dealing here with a continuous example, our probability will now be equivalent to an area. So there is no way that we can actually list down all the possible outcomes of this experiment and assign a probability value to that. Actually, if you try to do that, which is the second question right here, what's the probability that the dart will hit the point 0.5 comma 0.5 exactly? The answer to that question is actually 0, because if you consider this outcome with the rest of the possible outcomes in the sample space, the ratio of area between this guy and the other points in the sample space would be relatively small, and we, for convenience, we just assign it with a value of 0. That leaves us with answering the first question: what is the probability that the ordered pair or the point x comma y uh, uh, would satisfy this inequality right here, which is the sum of the x and y coordinates would be less than or equal to 1. So for the continuous case, the probability is equivalent to area, and this is how you solve that particular question. So first, we shade the region in this diagram that fits this equation. So x plus y would be a line, and that line includes the points 1 comma 0 and 0 comma 1. Now, since we have this inequality sign right here, we just need to choose between the two regions. And since this one is less than 1, so we choose this area right here. Now, looking at it, we see that the yellow region right here is actually half of the total area of the square. And so the answer to this probability question is 1/2.